Welcome to the lesson Comparator Circuits. In this lesson, we will talk about analog voltage comparison. There are many applications where we need to compare two analog voltages, and based on that, we decide which is high and which is low. Analog comparator IC do the same thing. So here is the comparator diagram. It has two input pins. One is non-inverting input and the another one is inverting input. And this is single supply type of comparator, hence it has only one supply, which is plus VDD, and here is the ground pin. It has one digital output pin. We can say comparators are mixture of analog and digital because it compares analog voltage and gives digital output. Now let's understand how this works. Keep these two statements in your mind. First one, when the voltage at non-inverting input is higher than that of inverting input, output will be high and equal to VDD. When the voltage at inverting input is higher than non-inverting input, output will be low and will be equal to the ground voltage, which is equals to 0 volt. Let's understand it with some examples. I'm having a LM324, which is a quad single supply type operation amplifier IC. Means this IC LM324 is having 4 op-amps which are single supply. This is the pin diagram of this IC. It can be used as a comparator. In our design, we will use this IC only. If the voltage at inverting input is 2.5 volt and non-inverting input is 3 volt, then output will be plus 10 volt, which is my supply voltage. If the voltage at non-inverting input is 5.2 voltage and at inverting input it is 5.3 volt, then the output will be low, which is equals to 0 volt. So this is how comparator works. Let's use some concepts of previous lesson here. We learn how to design a fixed voltage regulation circuit using Zener diode. So let's use that here. Set one input, say inverting input, to a fixed value which is called as reference voltage, and attach a varying analog voltage at non-inverting input. So whenever the voltage at non-inverting input will go higher than reference voltage, we'll get a high signal from output, else it will be low. Let's make it more of sense. Connect a sensor output in the non-inverting input and connect a buzzer in the output. So whenever the sensor value goes beyond this reference value, the alarm will start and you will get a signal that something is fishy. Now similarly, we also have a comparator IC which is LM339. It is also a quad comparator IC, but the difference is it has an open collector output. It means if we look at the internal circuit of this IC, then this transistor, the collector of this transistor is not connected anywhere. So we need to add a resistors from supply to output in order to complete this circuit, and then only we will be able to get the output. So if we connect a resistor here, then this will work same as the previous one. So I hope the concept of comparator is clear to you, and so see you in the next lesson.